So let's do a few economic examples of graphing nonlinear functions not using calculus. If we remember way back when, we defined something called an inverse demand function, which is P, let's just say it's P equals 48 minus 3Q. Okay, and so that would be our inverse demand function. Of course, demand would be Q on the left, everything else on the right. This is inverse demand because price is on the left and everything else on the right. Now, in functional form, we wouldn't write it like this. We would say price as a function of Q equals 48 minus 3Q. Okay, so this is proper functional form. Now what we're going to do is we are going to graph a profit function given the price of the product and the total cost of the product, which takes the form C of Q equals 6Q plus 120. Now we need to get revenue because remember profit is total revenue minus total cost. Probably all is a function of Q. What is total revenue? Well, it's P times Q. So P of Q times Q equals 48 minus 3Q times Q. And that is total revenue. So this equals 48Q minus 3Q squared. So now we have profit. Profit, pi of Q, is total revenue, 48Q minus 3Q squared, minus cost. So remember now, that's minus cost. We have to distribute this minus sign through. So that is minus 6Q minus 120. So now we're going to combine and simplify and rearrange to make it appropriate to put into the quadratic formula. And we get negative 3Q squared, that takes care of that, plus 42Q, that takes care of that and that, minus 120. And that is our profit function. Okay, so now let's graph profit. So we have Q on the horizontal axis, we have profit on the vertical axis. So now what do? Well, just like we always did with x's and y's, we first solve for pi of 0. Pi of 0 equals negative 120. Now that may seem weird, but it makes sense. Why? Because this right here, that's fixed costs. If I'm producing nothing and I'm fully shut down, I still owe my fixed costs. Therefore, my profits are going to be negative by the same amount of my fixed costs. Okay, so if I fully shut down, I can send my workers home. I can stop buying products I need to fulfill production obligations. I can turn off the electricity. I can turn off the natural gas. But what I can't do is avoid paying my lease, okay? Because my lease I'm contracted into for a long period. And so you could think of this as still my lease payment. Okay, so this makes sense. So this point is going to come into play here when we graph this profit function. Next step, what do? We run this through the quadratic formula, but now we're looking for Q, not X, because we're looking for the Q-intercepts. So Q equals negative B, which would be negative 42, plus or minus the square root of B squared, 42 squared, minus 4, times A, which is negative 3, times C, which is negative 120. Okay, all over 2 times negative 3. So this equals negative 42 plus or minus the square root of something that I'm going to break out my calculator for. So 42 squared is 1764 minus, what is that? That is 12 times 120 minus 1440, all divided by -6. Okay, so this equals -42 plus or minus the square root of, let's see, 1764 minus 1440 equals 324. Let's see, let me put this, I've got a new calculator here and I'm still trying to figure out how to work it. Okay, that's right. 18. Divided by -6. So this means Q equals -42 plus 18 divided by -6. Or Q, oh, I'm getting off the side of the page here. Sorry about that. Or Q equals -42 minus 18 divided by -6. Okay? So this is -42 plus 18 equals -24 divided by -6 equals 4, or Q equals -42 minus 18 divided by -6, 10. So those are my two quantity intercepts, 4 and 10. So you can see already what my profit function's doing. It's coming up and around. Here's the thing though, where's the axes? Because at the axis, that is where I'm maximizing profit. So if you remember way back when, we maximize profit where marginal revenue equals marginal cost. Well, if we have a full profit function, maximum profit is going to be at the peak of the profit curve, and that is also where marginal revenue equals marginal cost. We'll figure that out in later videos and when we cover other material and using calculus. But right now, where's the axis? Well, we've got what, 6 units in the middle here, so we're looking at the center being 7. So that is my profit maximizing output level. Now what is profit at 7? Then we would plug this into the profit function. Okay, so pi of 7 equals -3 times 7 squared plus 42 times 7 minus 120. So this equals 49 times -3, so that's 49 times 3. This equals -147 plus 42 times 7, which is 294, minus 120. So this is -147 plus 294 minus 120 equals 27. So my profit function looks like this. The peak of it is at 7 units. That's my profit maximizing output level. And the amount of profit at 7 units is equal to 27. And that's a profit function. Let's do a couple more. Well, let's do one more anyway. Okay, so we've got inverse demand. let's say it takes the form 72 minus 4q. We've got total cost. Excuse me, this is P of Q. Sorry about that. Total cost is, we'll say, takes the form of 16Q plus 180. Total revenue would be P of Q times Q. That will equal 72Q minus 4Q squared. So now our profit function takes the form 72Q minus 4Q squared, which is total revenue, minus total cost, 16Q minus 180. We're going to rewrite this and simplify. Gives us negative 4Q squared. 72, what is 72? 72 minus 16 is 56 plus 56Q. It takes care of that and that, minus 180. So that's my profit function. So now I'm going to solve for pi of 0. Pi of 0 is negative 180. Draw me a couple of axes over here for profit and quantity. At 0 quantity, I still have to pay my fixed costs. I still have to pay my 180. Okay? Now we're going to run this through the quadratic formula. So this means Q equals negative 56 plus or minus the square root of 56 squared minus 4 times negative 4 times negative 180, all divided by negative 8. So this equals negative 56 plus or minus the square root of something. Let's see, 56 squared minus 4 times negative 4 times negative 180 equals 256. Okay, divided by negative 8. So this equals negative 56 plus or minus, what's the square root of 250 of the square root of that? Let's see. Wait, hold on. Messed up my calculator. There you go. 256. That's 16 plus or minus 16 divided by negative 8. So Q equals, that looks like negative 40 over negative 8, which is 5, or Q equals, that would be 56 minus, that would be negative 66, negative 72, divided by 8, which is 9. Those are my two Q-intercepts, 5 and 9. So where's my vertex? Well, it's going to be at 7. It's going to be halfway in the middle. I mean, my axes. It's going to be at 7. It's going to be right in the middle. So we have 7 units again is my profit maximizing output level. How much profit am I making at that level? Well, that would be pi of 7, and I'm going to plug it back into here. Okay, so pi of 7, I'm going to plug it back into here. So that's pi of 7 equals negative 4 times 7 squared plus 56 times 7 minus 180. This equals negative 4 times 49 plus 56 times 7, which is 392 minus 180. So that is negative 4 times 49. Okay, that plus 392 minus 180 equals profit at 7 units is 16. So my profit function looks like that. Okay, and my profit maximizing output level is 7. I'm making 16 units. I'm making 16 units of profit, whatever that is, at 7 units of output. Let's do one more. Let's say P of Q equals 750 minus 5Q. So then R of Q equals that times Q, which is 750Q, excuse me, I don't know why I can't write today, 750Q minus 5Q squared. We'll say total cost takes the form 100Q minus 20,000. So our profit function then, pi of Q equals 750Q minus 5Q squared minus 100Q. Excuse me, this is a plus here. I don't know. You don't have negative fixed costs. Minus 20,000. So go back and change that to a plus sign right there. You don't have negative fixed costs. You got positive fixed costs. Those are the fixed costs. Okay, so rewriting this profit function and simplifying, we get negative 5Q squared. Takes care of that. Negative 100Q plus 750Q equals plus 650Q. Takes care of that and that. Minus 20,000. Okay, so again, we're going to make our profit graph, Q on the horizontal axis, profit on the vertical axis. At pi of 0, when we're completely shut down, our profit is negative $20,000, let's just say. So we have negative 20,000. Okay. Plugging this into our quadratic function, we get Q equals plus or minus, excuse me, equals negative 650 plus or minus the square root of 650 squared minus 4 times negative 5 times negative 20,000 all over 2 times negative 5, which is negative 10. So then Q equals negative 650 plus or minus something. Let's see what that something is. It's 650 squared minus 4 times, is that negative 5? Yeah, negative 5. Negative 5 times negative 20,000. That is the square root of 22,500 divided by negative 10. So Q equals negative 650 plus the square root of 22,500 divided by negative 10, which equals 50, or Q equals negative 650 minus the square root of 22,500 divided by negative 10, which is 80. Okay, so here's 50, here's 80. Where's the axis? Well, there's 30 units between there, so it's going to be this plus 15. It's going to be at 65. So 65 is my profit maximizing level of output. What is our profit at that output level? So that would be pi of 65. And going to my calculator, I get negative 5 times 65 squared plus 650 times 65 minus 20,000. That gives me 1125. So at 65 units, I've got a profit of 1125. And that is my profit function. Comes up like this. And that's graphing profit once again. So this is an application of what we've been doing for a little bit now, just applied directly to economics, directly to profit functions. And this is what's meant by profit maximization. We're going to see when we get into calculus mathematics that this that the concept of marginal cost